There is a planet out there that looks like a perfect blue sapphire hanging in the black. From a distance, it is the most beautiful world you could ever imagine. But here is the question that should haunt you. Is that beauty real, or is it just a mask for something horrific? The truth is that this stunning blue gem is actually a vision of hell. It is a place where the very air would kill you in an instant. And the winds there scream across the sky at 8,700 kilometers per hour. So, what would it feel like to stand on a world that is both so beautiful and so violent? We live on a world situated at a perfect distance of about 150 million kilometers from our sun. That number, 150 million, is not just a random figure. It represents the delicate balance that allows water to stay liquid on our surface. Our planet is a beautiful blue orb, a color that comes directly from the vast oceans covering more than 70% of it. When you look at Earth from space, you are seeing a world of water, and that water is the very foundation of all life we know. We look at this familiar blue and usually think of calm seas and gentle rain, but our world has its own powerful tempo. The strongest winds ever recorded on our planet came from Typhoon Tip in 1979, a colossal storm in the Pacific Ocean. According to the World Meteorological Organization, the winds in that storm reached an astonishing speed of 305 kilometers per hour, a number that sounds terrifying to us. We look at a number like that and consider it to be the absolute peak of nature's fury, the very limit of what a planet's atmosphere can do. It is our frame of reference for danger, the most extreme weather our home can throw at us, a force capable of leveling entire cities. We use that number to judge all other storms because it represents the maximum possible violence our atmosphere can generate. Think about the fact that a wind of 300 kilometers per hour can flatten forests and tear roofs from buildings, and it feels like the ultimate natural disaster. But now imagine a planet where that speed is just a gentle breeze. Picture a world where 305 kilometers per hour is nothing more than a mild summer day. That is exactly the sort of place we are going to explore next, because we have found worlds beyond our own that make our most violent storms look calm. What would it mean for a planet to be so different from ours? But before we chase those alien storms, we need to understand what makes our planet so special in the first place. Earth sits at a comfortable distance of about 150 million kilometers from the sun, a sweet spot that scientists call the habitable zone. This is the region where temperatures allow liquid water to exist on a surface, and we are right in the middle of it. At this distance, the sun's energy warms us just enough to keep oceans liquid, yet not so much that they boil away into space. The result is a world covered in deep blue oceans, which are the reason our planet looks so vivid from orbit. When astronauts look back at Earth, they see a blue marble, and the color is not a trick of light. It is the literal reflection of our seas, which cover more than 70% of the surface, a vast expanse of water that defines our home. That blue is the color of life as we know it, because water is the solvent for every biological process we understand. It is the same water that cycles through clouds, rain, rivers, and glaciers, creating the dynamic weather systems we all take for granted. And our weather, for all its drama, is actually quite gentle in cosmic terms. Hurricanes and typhoons are the most violent storms we know, and they form only under very specific conditions of heat and moisture. A storm needs warm ocean water, humid air, and a spinning planet to become a powerful cyclone, and even then, the energy is limited by our sun's input. That 305 km per hour figure from 1979 was a freak event, a perfect combination of factors that lasted only a few days. The atmosphere of Earth simply cannot sustain winds beyond a certain threshold, because the temperature differences between air masses are too small. Our planet's rotation, its oceans, and its greenhouse gases all work together to keep things balanced. This stability is why life has been able to survive here for billions of years in a relatively calm environment. We are so used to this safety that we assume any planet with weather must be like ours. So when astronomers discovered a world called HD 19733b, they were shocked at how different it is. That planet orbits its star at only 4.8 million kilometers, a distance that puts it more than 30 times closer than we are to the sun. This means it is bathed in intense radiation, its atmosphere heated to thousands of degrees, and the resulting winds are beyond anything our minds can grasp. The very concept of a blue planet becomes twisted there because its color comes from silicate particles in a toxic haze, not water. Now here is the question that changes everything. If we ever find another planet that appears blue like ours, could it be another Earth, or could it be a nightmare world in disguise? Now let's move past the familiar blue of our own world. Out there in the constellation of Vulpecula, about 63 light-years from home, there's a world that makes our oceans look like a pale imitation. HD 19733b. When you first see it, you think, that's it, that's the gem of the galaxy. A deep, rich sapphire blue so brilliant and pure it seems to have been carved from the sky itself. It's the kind of color that would make you believe you've found a water world, an ocean planet, a place that might cradle life in its warm blue depths. But here's the problem with first impressions. They are almost always wrong, and in this case, they're not just wrong, they're dangerously, spectacularly, terrifyingly wrong. That gorgeous blue isn't water. It's a lie, a beautiful, shimmering illusion painted in molten glass. To understand how we even know what color this distant world is, you have to appreciate the sheer cleverness, and maybe the sheer madness, of the people trying to measure it. In 2013, a scientist named Tom Evans at the University of Oxford led a team that did something no one had ever managed before. They used the Hubble Space Telescope to actually measure the color of an exoplanet for the very first time. Think about that for a second. This planet is 63 light-years away. That's roughly 600 trillion kilometers. We can't send a probe there. We can't take a photo of it. Any direct image would just be a single pixel of light. So how do you figure out the color of something you can barely see? The answer is spectroscopy. You collect the light reflecting off the planet, and you split it, like a prism splitting sunlight into a rainbow. Every element, every compound, leaves a distinct fingerprint in that rainbow, a unique pattern of dark lines and bright colors. You can't see the surface, but you can read the light it throws back at you. That is the trick. That is how you catch a ghost. So the team pointed Hubble at HD 29733b, and they waited. They carefully filtered out the light from the star itself, isolating only the tiny fraction of light that had bounced off the planet. And what they found genuinely startled them. The spectrum was unmistakable. The planet was blue. Not just any blue, but a deep, vivid sapphire blue. For a moment, you could be forgiven for letting your imagination run wild. Blue, you think water. And where there's water, there might be life. But then you look at the data more carefully. You zoom in on the specific wavelengths, and the fantasy falls apart. The signature they found didn't match the reflection of liquid water. It matched something else entirely. Silicate particles. Microscopic grains of glass suspended in a hazy atmosphere, that's right. The stunning serene sapphire glow of HD 8933b isn't the sparkle of an ocean. It's the light scattering off a sky filled with tiny glass beads. It's the same reason our own sky appears blue. Light scatters off the molecules in the atmosphere, and the shorter, blue wavelengths get bounced around more. But here, the scattering is happening off droplets of molten glass, and that changes everything. The beauty you're looking at isn't a sign of life, it's a warning. It's the visual signature of a world intent on killing anything that comes near it. The color that promises calm oceans is actually the color of a storm that never ends, a storm that rains sharp, solidified shards of glass sideways at unimaginable speed. The universe has a sick sense of humor. It paints its most lethal worlds with the colors we've learned to associate with peace and tranquility. From a distance, H1033b is a treasure, a sapphire floating in the dark. But get close and you'll realize the treasure is poisoned. The ocean is a furnace. The sky is a hurricane of glass. And the blue, that heartbreakingly beautiful blue, is just the first layer of a nightmare. So if a world this beautiful can hide a reality this violent, what does that say about the lessons we draw from the colors we see here, on our own one safe blue oasis? Now let me tell you what the weather is actually like on this beautiful blue world, because it makes every hurricane on Earth look like a gentle breeze. We're talking about wind speeds of roughly 8,700 kilometers per hour, which is about 7 times faster than the speed of sound on our planet. Let that number sink in for a moment, because there is nothing on Earth that comes anywhere close to that kind of atmospheric violence. The strongest gust ever recorded in a tornado was around 480 kilometers per hour, and that was enough to rip houses clean off their foundations. Now multiply that by 18 and you start to get a sense of what a single day on HD 899733b feels like. So what causes this insane weather? The answer lies in something astronomers call the heat-wind paradox, and it is a beautiful piece of cosmic physics. The planet is locked to its star, meaning one side always faces the burning sun while the other side sits in permanent darkness. The day side heats up to around 200 degrees Celsius, while the night side drops to a comparatively chilly 800 degrees. That 400-degree difference between the two faces creates an enormous pressure imbalance in the atmosphere, and nature absolutely hates imbalance. The atmosphere tries to equalize, and it does so by rushing from the scorching day side to the cooler night side at supersonic speed. If you want to understand this mechanism, think about what happens when you open an oven door on a cold winter morning. The heat rushes out violently, but only for a second, because the temperature difference is small. Now imagine the same effect with a difference of 400 degrees, stretching across an entire planet, and you begin to grasp the scale of what is happening there. This is not a gentle breeze we are talking about. This is a planet-wide jet stream moving at Mach 7. And now here is where the story gets truly terrifying. because those winds are not just carrying air, they are carrying liquid glass. The atmosphere of HD 189733b contains silicate particles, which are the same basic material that makes up the sand on Earth's beaches. At the temperature of the dayside, those silicates melt into molten droplets. And then the 8,700 km/h winds catch those droplets and hurl them sideways, completely horizontal, so fast that they never get a chance to fall. The rain on this planet does not fall downward, it flies straight at you like millions of tiny red-hot glass bullets. A team led by Tom Loudon and Peter Wheatley at the University of Warwick measured these wind speeds in 2015 using the Very Large Telescope in Chile, and they did it by analyzing the Doppler shift of carbon monoxide molecules in the planet's atmosphere. When they realized what they were looking at, they knew they had found something extraordinary, a world where the weather itself is a weapon. So the blue jewel in the sky is not a paradise, and it gets even worse when you start thinking about the heat alone. Now, let me be very clear about what 1,000 degrees Celsius actually means here on Earth. It is the temperature at which zinc and lead don't just melt. They boil away into a toxic vapor, vanishing from a solid pan into the air before your eyes. That is precisely the kind of heat that defines the surface of HD 19733b. When the data from the NASA Exoplanet Archive painted this picture, it revealed a world where the very concept of a solid surface is a distant memory, and the atmosphere itself is a sea of vaporized metal. You wouldn't even find a place to stand, because the ground, if it exists at all, is a superheated, glowing sludge. So, when we talk about 1,000 degrees there, we are not talking about a hot summer day. We are talking about a temperature that fundamentally breaks the rules of matter as we know them. It is a heat that doesn't just burn, but transforms, and it is the engine for every other nightmare on this world. Now, to really understand how a place like this works, let me give you a simple two-step guide to thinking about a hot Jupiter like this one. Step 1 is to forget everything you know about weather on Earth. Our weather is driven by the sun heating the ground, which then warms the air. But on HD 9733b, the heat is so immense that it is the entire story. Step 2 is to understand that this isn't a planet with an atmosphere. It is an atmosphere with a planet somewhere at its heart, a churning, glowing ball of gas where the distinction between air and rock is completely blurred. Once you grasp that, the idea of liquid glass raining sideways doesn't seem so strange because you are essentially standing inside a giant scalding pressure cooker. The very air you would try to breathe is a cocktail of vaporized rock and metal. And there is nowhere to hide from the relentless, crushing heat. It makes you wonder how any world can be this hostile. As this superheated vapor rises, it cools slightly, and this is where the real magic of the horror begins. The silicate that is vaporized in the planet's extreme heat condenses into liquid, not solid, droplets of glass. According to NASA science, these droplets don't have time to freeze into the sharp shards we think of, because the temperature is still far above the melting point of rock. They fall through the sky as scorching, liquid projectiles, moving at thousands of kilometers per hour. Only as they descend toward the cooler, deeper layers of the atmosphere near the core do they finally solidify, turning into the more familiar, solid form of glass. Just imagine standing there, if you could survive for a single second, with boiling glass pelting you from every side at that velocity. The very idea of rain, a source of life on Earth, is twisted into an instrument of annihilation, with each drop a tiny molten star designed to burn through anything it touches. The beauty of this planet's blue hue becomes a sick joke when you realize what that color actually represents. The fury of this heat is further amplified by the star it orbits, HD 1933a. This orange dwarf star is smaller than our Sun, but it is a far more violent neighbor. As the NASA Exoplanet Archive notes, it is prone to powerful stellar flares, unleashing torrents of X-ray radiation that scour the planet's atmosphere. These aren't just gentle waves of light. They are violent storms of energy that blast the already torn atmosphere, heating it further and driving the ferocious winds that carry the liquid glass. So you have a star that is actively bombarding its planet with destructive radiation, while the planet itself tries to melt, vaporize, and batter anything that comes near. It is a complete coordinated assault on the very idea of existence. The scale of the destruction is so complete that you have to step back and marvel at the raw, unfiltered power of nature. And when you put all of these elements together, the image is so absurdly violently destructive that it almost becomes a joke. This place isn't just hellish, it is a cosmic warning about what a universe without mercy looks like. But the horror show doesn't stop with the temperature, because this heat is also the driving force behind something even more terrifying. A maelstrom of wind and pressure that defies comprehension. The real horror of HD 189733b isn't just the wind or the heat. It's the fact that this world is locked in a permanent cosmic stare, Because it sits so close to its star, the planet is tidally locked, which means one hemisphere always faces the burning sun, while the other is trapped in an eternal frozen night. There is no day and night cycle, no gentle sunrise, no evening cool down, just a single unending firewall on one side and a deep cold abyss on the other. This isn't a planet that rotates. It's a world that is forever stretched between extremes, and that static divide creates a temperature difference of over 500 degrees Celsius between the two faces. Scientists at the Harvard-Smithsonian Center for Astrophysics, led by Heather Knutson, mapped this out in 2007 using the Spitzer Space Telescope, watching the planet for over 33 hours straight. They didn't just find a hotspot. They found a massive searing region that had been pushed away from the noon position by those violent winds, a scar carved by the planet's own weather. Now, imagine trying to stand on that surface. Even before the wind hits you, the pressure alone would crush you instantly, and the gravity, at 1.13 times that of Earth, would make every movement a battle. You would be flattened before you could even register the danger. And if, by some impossible miracle, you survived that, the star itself is actively trying to tear the planet apart. It bombards HD 19733b with powerful X-ray flares so intense that they blast the atmosphere away at a rate of about 1,000 tons every single second. The planet is literally evaporating, being blown into space by its own sun. That radiation is also stripping away hydrogen, meaning the world is losing water on a catastrophic scale. To read the scientific reports on this, you first have to separate the observable data, like the temperature readings, from the theoretical models, and then you have to remember that every number you see represents a process that is actively destroying a planet. The image you're left with isn't a world you could visit, it's a world that is violently unmaking itself, and it makes our own fragile blue marble feel impossibly precious. The first step in reading any exoplanet report is to locate the equilibrium temperature, which is a theoretical baseline that assumes no atmospheric circulation. For HD 19733b, this number is a scorching 1200 Kelvin, but the real story is in the deviation from that baseline. The second step is to scrutinize the day-night temperature contrast, which the Spitzer data placed at a staggering 500 degrees Celsius. That single metric tells you more about the planet's atmospheric dynamics than 100 pages of theory. It tells you that heat is not being redistributed effectively, that the winds are howling in narrow, brutal jets rather than mixing the air, and that the night side is a glacial abyss compared to the inferno on the other side. When you read about a hot Jupiter or an ultra-hot Neptune, this is the kind of data you are actually looking at, a thermal signature that defies every comfort zone we know. You are not reading about a place. You are reading about a process of extreme energy transfer. And once you understand that, the next question becomes terrifyingly clear. What would that process feel like on your skin? The wind would be a hurricane of glass-like silicate particles, superheated to the point of glowing, moving at 7,000 kilometers per hour. The air itself would be a thick, poison fog of sodium and magnesium, a choking broth that would strip the flesh from your bones. The temperature differential alone would cause your body's fluids to boil and freeze simultaneously, a gruesome paradox that no emergency system could counter. So, when a headline screams about a new Earth-like planet, what you are really being told is that it has a rocky core and an atmosphere, not that it has a weather forecast you would ever want to live in. You have to read those reports with a cold, clinical eye, looking for the numbers that describe the planet's death, not its life. That shift in perspective is what turns a casual reader into a critical thinker. You check the radiation flux, you check the tidal locking period, and you check the atmospheric escape rate, and if any of those O's are high, you know the planet is not a sanctuary, but a tombstone. What we have here on Earth is a fragile miracle of climate, a system so finely balanced that the slightest nudge spells disaster. But on that distant world, the entire climate is a single, screaming catastrophe. We are not reading about a destination. We are reading about a warning, written in the language of boiling rock and shrieking winds. A warning that the cosmos is not kind, and that our blue oasis is the exception, not the rule. As we look for a place to escape to, we should first remember this glass rain world, which shows us exactly what our solar system would be like if its order was ripped apart by a larger star. It is a humbling, terrifying notion, and it is the final undeniable proof of our own planet's fragile grace. But wait, there is a world out there that makes this one look like a gentle breeze. A world where the very concept of a surface becomes a philosophical question. You think you have seen the most terrifying place in the universe with HD 19733b, with its sideways glass rain and 7 times the speed of sound winds. But here is the uncomfortable truth that puts our sapphire nightmare into perspective. It is not even the most extreme world we have found. There is a planet out there called WASP-76b, and its winds have been measured at a staggering 4.5 kilometers every single second. Let that number sink in for a moment. To translate that into the language we used earlier, that is over 16,000 kilometers per hour, which is nearly double the wind speed of HD 19733b. We thought we had found the benchmark for atmospheric fury, and then the universe simply raised the stakes. So the question we have to ask ourselves is this: if these are the conditions on worlds we have only just begun to study, what else is hiding out there in the dark? The sheer diversity of these hellish landscapes forces us to confront just how small our understanding really is. But before we get lost in the existential dread, let me tell you why HD 1897333b still holds a special place in the Scientific Hall of Fame. Discovered back in 2005 by Francois Bouchy and his colleagues at the TESS Institute of Astrophysics, using a modest 1.93-meter telescope at the Haute-Provence Observatory in France, this planet initially seemed like just another ordinary find. The team thought they had found a typical hot Jupiter, nothing particularly remarkable at first glance. But then something crucial happened. As they gathered more data, they realized there was a real possibility that this planet transited, meaning it passed directly in front of its host star from our point of view. They immediately alerted the global astronomy community so that every telescope on Earth could turn its gaze toward this new discovery. That quick thinking and open communication turned HD 1897333b into one of the most intensely observed planets in the history of astronomy. Had it not been for that rapid response, we might have missed our chance to study it in such incredible detail. This single moment of scientific collaboration is why we now have over 300 published papers about this one world, according to the NASA Exoplanet Archive as of 2024. 300 papers about a single planet that looks beautiful, but would kill you in an instant. That is what happens when you get the timing right. And that is why HD 1897333b has earned its place in what astronomers call the golden sample, a select group of exoplanets that the James Webb Space Telescope can observe in extraordinary detail. The planet's orbital geometry is so perfect that we can measure the starlight filtering through its atmosphere, allowing us to essentially read the chemical fingerprint of a world that exists over 60 light-years away. In a way, this planet became our first real classroom for understanding how to study atmospheres beyond our solar system. Now, think about the bigger picture for a moment. We have one planet with glass raining sideways, and another one with winds that would tear you apart in a heartbeat. The more we look, the more we realize that the universe is not a gentle place, and yet here we are, on this fragile blue marble, trying to make sense of it all. So the real question becomes even more profound. How does a planet like Earth even exist in a cosmos that seems so determined to be hostile? After all the comparisons and the terrifying statistics, that is the mystery that truly deserves our wonder. Because the extremes are not just about shock value, they are about understanding our own unlikely place in the grand scale of everything. That sapphire world we pictured at the start, the one that glows like a jewel against the black, is a place where beauty and annihilation are the same single fact. We have seen that its color comes not from oceans but from glass, that its gentle blue light is the glow of a worldwide storm, and that its winds move at speeds that would tear any structure we have ever built to pieces. We have learned that its surface is hot enough to boil metals, that its rain falls sideways, and that its star blasts it with radiation powerful enough to strip away 1,000 tons of its atmosphere every single second. And yet, for all that, it is not even the most extreme place we have found. There are worlds where the wind moves even faster, where the sky rains iron, where the very concept of a day is forever frozen into a single burning stare. The universe is not a gentle place, and we are only beginning to understand just how violent it can be. So what does that mean for us, for our small blue planet with its liquid water and its gentle breezes? Does it make our home feel more precious, or does it make our existence feel more fragile, a brief accident in a cosmos that is mostly hostile? Perhaps the answer is both. But here is the thing that stays with me. We have only just started looking, and already we have found a world that defies everything we thought we knew about weather, about planets, about what is possible. Every new telescope, every new observation brings another surprise, another place that makes our Earth seem stranger and more special at the same time. The next time you look up at a clear night sky, remember that out there, somewhere, a blue world is shining, beautiful beyond imagination and utterly deadly. And that is just one of trillions.